Hi, this is my presentation for IoT in agriculture. So, IoT is a network of physical devices that can connect and exchange data with similar devices on the internet. The use of IoT in industrial context is also known as industrial IoT. Early farming practices involves human labor, animals, and simple tools. Tractors and machineries was then introduced to reduce most of the physical work required. The concept of precision farming was then introduced where farmers will observe and measure certain parameters before responding depending on the data collected. So there are four key components of IoT in agriculture. Is physical structure, which refers to the sensors and controllers; data acquisition, which refers to data acquisition using IoT protocol, using standard or IoT protocols; data processing, which involves image processing and decision support systems; and lastly, data analytics, which refers to monitoring and controlling of the physical structures. This is how the overall network architecture will be depicted. Sensors and actuators are connected to the CPS nodes via direct I/O connectors. The CPS nodes are then connected to the internet to send the data. At the edge computing plane, this layer mainly contains a set of network function virtualization control modules that will manage and coordinate the CPS layers. Data fusion and aggregation is carried out here to reduce any burden on the cloud plane. The data cloud is then used as means to maintain the current state of the crops and configuration and parameters by serving as an interface between users and core platform. MQTT is a message-based protocol that uses publish-subscribe model. It uses TCP for transport and its architecture centers around the clients and servers. It's a lightweight protocol, but every client needs to be able to support TCP and will need to hold a connection open. COAP is a web transfer protocol that has similar architecture to HTTP, but is catered for constrained environments. It uses UDP for connectionless communications. XMPP is a protocol mainly used for messaging, but it's not very efficient for its bandwidth use. AMQP is a protocol that can operate between application and systems, but is very resource intensive, which makes it more suited for use between servers and powerful nodes. DDS is used for real-time systems that demands high-speed data sharing and is ideal for big IoT deployments where multiple devices and sensors are required to exchange data rapidly and efficiently. REST HTTP, like HTTP is stateless. Since it's stateless, request sent by client to server needs to include all the details required for a server to fully understand and handle it. Like COAP, it's also more suited for web-based communications. WebSocket is a full duplex bidirectional communication channel using TCP connection. With this feature, the client and server can send continuous information without needing to re-establish any connection. On this slide, we are comparing main IoT protocols based on their suitability for smart farming. For latency, COAP, WebSocket, and DDS are ideal for real-time applications due to their low latency. Any energy efficiency is critical for devices in the field, where MQTT and COAP perform well. But for scalability, MQTT, DDS, and AMQP handle large networks effectively, important for complex farming setups. Reliability varies with MQTT and AMQP, ensuring uh, dependable message delivery, essential in critical scenarios. Security is built into XMPP and AMQP, while others like COAP requires external layers. Lastly, compatibility is generally high across protocols, allowing flexibility in deployment. Each protocol serves different needs, balancing efficiency, reliability, and scalability based on farming applications. So, in conclusion, depending on requirements like latency, energy efficiency, and scalability, each protocol covers different aspects of farming, ranging from data collection in the fields to real-time decision making in the greenhouse. MQTT and COAP are protocols that are applicable for scalable, energy-efficient sensor networks, whereas DDS and AMQP are good at managing complex, data-intensive applications. IoT in agriculture has the potential to significantly increase precision, sustainability, and productivity through the efficient use of this protocol. That is all for today. Thank you very much.